Yeah, we're live. Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Mehrdad Abdollahi, the organizer and community lead of this great community. It is a pleasure to be here with another session. So, guys, we will wait a little bit for everyone to join, but in the meantime, I'm going to just share my screen and, as usual, so we've been off, for a week, and however, it is a weekly session for the Fabric conversations. So today is session number 43 in August 30th, 7 a.m. Pacific time in my end in Vancouver, Canada. So we are part of the Microsoft Learn community. So it is basically Microsoft Fabric Cafe is a learning room in that in between those learning groups in the community of Microsoft Learn. There you can just find other rooms as well and just join to any room that you're interested in, and you can be in touch with the experts and get support from your peers or even share your knowledge with them. And in Microsoft Fabric Cafe, we have weekly Fabric coffee sessions. We try to have the weekly sessions, uh, and we actually consist on that. So we almost 5,000 members, around the globe, and we are focusing on Microsoft Fabric and Power BI. So we provide learning and support to Fabric users in all levels. It is a forum for everyone to learn, share, and skills together. So there are some, ways to connect to us or follow us. It is basically on YouTube channel with the handler of Microsoft Fabric Cafe to just watch the live sessions like this, or even watching the past sessions that we had. We had lots of amazing sessions with amazing speakers. On our LinkedIn page, it is going to be just the announcements and updates from the community, from Microsoft Learn and Microsoft Fabric. So we've got two user groups. One is Microsoft Community Group there, and also Microsoft Fabric Community. We have the groups there, user groups there. You can start doing just discussions, asking the questions if you have any, and just help your peers as well. You can write blogs and blah 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 blah. So feel free to just join us there, and let's catch more. And we also have the meetup group where we do actually the announcements for our sessions. And what you can do there is do the RSVP and just rate the session after it is done, and you can connect with your peers as well afterward. But the rating is very important, and we do like to have your rating on the session. It shows how good or bad we are doing our job and how we can improve it. So there's a code of conduct in our live session and the community. Thank you very much for adhering to them. I'm not going to read all of them, but thank you very much. We have very good people. So the last session that we had with Vahid Ustimash was related to real-time intelligence. That was amazing session, amazing demo by Vahid. So you can just rewatch it if you missed that. You're gonna learn lots of things from source to the dashboard. It was a fantastic one, and it is available in our YouTube channel in the live section. And for today, I'm super excited to host another time Bas Land, and which is actually going to uh, around delta table optimization. I'm super excited to learn from him, and yeah, let's Let me just invite him to the stage. Uh, Hello, Bas. Welcome.
Hey, good morning or good afternoon.
Yeah, good morning, good afternoon, good evening. What time is it on your end, Bas?
4 p.m. here in the Netherlands.
Okay, nice. Thank you very much for being available during the weekend. Yeah, it is
Of course, of course.
really appreciated. It is the time off, of course, for most of us, for just being with family or getting some rest and being ready for the week. But yeah, thank you very much, and it is truly appreciated when you with actually the time that you put in your weekend. So yeah, guys, just let us know where you're connecting from if you would like, and uh, Bas, I'm really excited to learn about the Delta Lake optimization, which is very important. Delta tables, I mean, and
Mhm.
how it can be put in practice. When we are talking about optimization, and because the performance is always the first thing, right? In the enterprise data solutions. Cool. We have a comment from Skill Gain, if I'm not yeah, Skill Jane. Jen, I'm excited to hear about these optimization techniques. Yeah, like me, I thought liquid clustering was just a Databricks thing. Any comments on
It
that?
was it was brought to Fabric as well.
Yeah.
So I believe it's a Delta Lake thing now, which is enabled in Fabric, which we can use to optimize the layout, the physical layout of our Delta tables, which is quite a nerdy thing to be talking about. But we will be doing that today. So
Awesome.
I mean,
Awesome.
I
So
think in
I'm
this
not.
group we're ready to nerd out, right?
Yeah. So I'm going to just hand over the station to you. Bas, would you like to share your screen? And
I
guys, I
will.
will hand over the station to Bas, and you can just enjoy it, learn
Let
it,
me
ask your
check.
questions. Yeah.
All right.
Cool.
Cool.
Guys,
Can you see
enjoy
my,
it.
s- my Can you see
Yeah.
my slide here? Does it work?
Yeah. We are seeing that.
Awesome. Awesome. All right. So, welcome to the Delta Lake optimization session. Today, where we'll be looking at partitioning and clustering or liquid clustering best practices for Microsoft Fabric Delta Lakes. And no, that's not only for Databricks, it's also for Fabric. At least it is these days. So, a little introduction about me before we start to set the stage a little bit. My name is Bas Land. That's a very Dutch name. It's very difficult to pronounce in English. I know. Even I find it difficult to pronounce in English. But bear with me. And Bas is actually short for Bastion. So you can think of that when you think of my name. I've been a BI consultant in the Microsoft ecosystem since 2013. So I've seen everything from SQL Server, SSAS to Data Factory, Azure SQL, and now Fabric. So that's actually quite cool. In the last couple of years, I've been working with Fabric quite a lot. I'm the co-founder of Kimura, where we built a standardized data framework for Fabric, and that means that we do all kinds of Fabric and Power BI consultancy, which allows me to do Fabric stuff with a lot of our clients, and that's actually pretty nice to do because I can play with all the latest tech goodies that we get from Microsoft and get paid for it. So that's amazing, actually. In my personal life, I'm married to Anouk. A big thanks to her as well that she let me go on a Saturday afternoon to do the session with you guys. So grateful to her. I'm a dad to Oliver, our newborn. He's now 4.5 months old, and we have a little dachshund called Chester, our little doggy friend. And as you can see here on the photo, I'm feeding the baby while the other baby is also looking at us like, why did you feed me? Besides doing family stuff with my wife and son and doing BI stuff with Microsoft, I also like to do sports because sitting behind a laptop all day is not that good for you. Actually, I wouldn't wouldn't recommend doing that and then going home and then sitting again. So I try to keep moving. I do Brazilian Jiu-Jitsu, which is a grappling combat sports. I do some weightlifting and do some running, so I try to keep active. All right. If you want to follow me and see more of me or to discuss things with me, then you can follow me on LinkedIn, You can subscribe to my YouTube. That's pretty new. I think we're live now for little over a month. And you can check out the blog at fabricguy.com. You can also email me, but please do not email me your homework. I will not be doing your homework. But if there's little questions regarding this session, then send me an email and I'm happy to help you. The QR codes point to my blog and LinkedIn, I think. So if there's, some of the comments that I get from these sessions is that I go too fast through these slides and people cannot scan the QR code. So if you want to connect with me on LinkedIn, now would be the time to scan the QR code. 5, 4, 3, 2, 1. All right. The slides and the code samples that I will show you during the session today will also be sent to my public GitHub. So if you go to github.com/Bas Land, which is my first name and last name, /presentations, you will be able to find the stuff there as well. And then a little teaser for the performance stuff that we're going to increase by looking at how we can physically lay out our delta tables a bit better. We could achieve maybe a 10 or 20-fold increase in query times, depending on where we optimize and how large our tables are and so on, of course. So that's a little teaser for today. Why are we discussing Delta Lake optimization anyways, right? So what we have to know first is that Delta tables power our Fabric data platform. All right, so whether we're using Warehouse or Lakehouse, under the hood, everything is Delta, which is Parquet files with a transaction log and some other intelligent stuff around it in order to make it a queryable and transactable table. If you don't have an optimized Delta table, it could be sluggish, it can be slow, it can also be very expensive. And you know that if you're starting to implement data platforms for customers and they start talking about pricing and costs, so expensive is never a good thing. And most of all, for us as data engineers and consultants, it is very frustrating to work with very slow environments, which is not good for liking our job. So we can do so many nice things, so it should not be that frustrating. So we cannot have unoptimized Delta tables. As a modern data engineer, we must think physical about storage, about file layout, and so on again. I remember in my first job, I did some SQL Server data warehousing, and we were thinking about which database on the SQL Server do we put on what physical disk in the server. Why? Because we can maybe read from one database and write to the other database in parallel by splitting the databases over two different physical hard drives, right? We can have the I/O basically double by reading from one disk and writing to the other disk. And then we went to the Azure cloud and we started doing Azure SQL Database and Azure Data Factory, and then all of that went away because I couldn't manage the hard drives anymore. But now that we're working with Fabric, we should be thinking about physical data storage again. And I will be showing you today, of course, how that plays out. And then Delta Lake in Fabric gives us some powerful tools, but it also gives us some complexity. And with this talk, I will try to navigate through that for you guys. So what will you be learning today? You'll be learning about partitioning and how you can get query pruning for free. That's actually a very nice thing to work with. We will be looking at liquid clustering, which is a continuous optimization on write. So when you're writing data into a table, it will be optimized for you by utilizing liquid clustering. We will do some live benchmarks between partitioned, clustered, and not optimized tables. However, I have to warn you, we might be running into some demo problems because the tables that we need in order to actually show the benefits for partitioning and clustering are quite large. I'm not sure if I can actually demo that today. When preparing that, I had some troubles with the environment, but I will be showing you guys everything that we can show. We will also be looking at file compaction, because if we start talking about clustering and partitioning, especially partitioning, file compaction is a thing. We don't want to end up with many small files. That will be a very large problem for our Delta table. Oops, and then there will be some best practices and gotchas. Now, mind you, I will be going through the slides quite fast because I want to dive into Fabric and to do the live demo as early as possible. However, I do need the slides to set the stage a little bit in order to have the framework in which we can do the actual demo. If I'm going too fast, please let me know. Please break in and say, hey, Bas, you're going too fast. Can you slow down a little bit? That's perfectly fine. All right. So if we're looking at a delta table, then what exactly makes up our delta table? First of all, we have to talk about Parquet files. So we probably know about CSV files, about JSON files. We can also store data using Parquet files, and that is just a text file for structured data, right? It is the underlying file format for all delta tables that we create in Microsoft Fabric, and it has a columnar layout. Now, the people that work with Power BI semantic models with the Vertipack engine, they might know about how the column layout will speed up your read queries, especially for analytical purposes. You will probably never need to read all of the columns in a table. You will probably read 1, 2, 3, maybe 4 columns in a table, and that's it. So instead of organizing a table row by row, where you need to iterate through every row, reading the entire row into memory and then doing stuff with it, why not rotate your table basically 90 degrees, store column by column by column, and then when it's time to read, you need to only access those data sets, those columns that you're actually reading, right? That actually makes sure it's a lot faster because you're only reading a subset of your physical data. You also get statistics on the column level, which means that you can start skipping data, and there's more optimization that we can apply there, and that's the purpose of this talk today. Because we're working with a column by column data storage, we can do column compression, and that's on by default. So Microsoft or Delta Lake actually arranged for us to have a compressed data storage, and that means that we have lower storage costs, although storage in Fabric is quite cheap. We also have less I/O, and that means that doing less operations means our queries are faster and our platform is cheaper, so that's actually quite nice. A Parquet file is therefore also the foundation to our Delta Lake tables, which is the purpose of today. So what is then a delta table? A delta table consists of 3 things basically: one Parquet file or multiple Parquet files, a transaction log, and asset. And I always forget what asset actually stands for, but I put it on the slide here, which means that we can do merge, update, and delete transactions on tables as if it were a relational database table. Where asset stands for atomic, consistent, isolated, and durable, which basically means that we can now I'm lost for the words, which basically means that we can guarantee that the transaction goes through, that it's not interfering with other transactions, and that the data that we get out of it is consistent. So when we run a query against a delta table, how does it actually work? Because we have a bunch of Parquet files in a folder that we call a table. How does that work? So the delta table is a set of files that we need to query as if it is a table. Okay, so when we do the query execution, a few things happen. First, the SQL query or Spark query is submitted to the Spark cluster. The cluster then reads the delta log, the transaction log, to find the latest snapshot. All right. So you can imagine that if you start doing updates and deletes and inserts into a delta table, you are not actually inserting data into a Parquet file. You're inserting a new Parquet file into the table. And then the transaction log, the delta log, is keeping the history of all that is happening. And when you run a query, the delta log then actually tells you need to read that file and that file and that file. And that is the most recent representation of your table. Min and max stats are being used to prune files, which basically means to select files, or actually to leave out files out of the read. That means that we don't need to spend compute power on everything that's happened in the past on our tables. And only the relevant Parquet files are then scanned, and within those files, actually only the relevant columns are scanned. So that actually makes it quite efficient. The result set is then being prepared, being sent back from the workers to the master, and then the data can be presented, whether it's directly to the client application or to a data frame or to any other intermediate step. So what are we optimizing for if we start optimizing delta tables? We start optimizing for fewer files to be scanned. Okay, so we want as little files as possible during query read. Because it results in less I/O operations and faster queries. We want smaller file sizes if we can. Smaller is not always better, because a smaller file means automatically we have more files, so there's a balance that we should aim for there. But smaller file sizes usually go for faster read, because there's easier caching and more of the data actually will fit into our query cache. Then the file layout itself matters, because if we can start skipping data from columns, we don't have to go through as many data in order to find the answer we're looking for. And we want to have a lower shuffle volume, which creates more efficient joins and aggregations by laying out the rows in our tables in a way that we can more easily aggregate them. All right, so we want fewer file scans with a lower file size, a clean file layout so that we can skip columns, and a low shuffle volume, which basically means sorting the table in order to be able to read big chunks of rows. So that's the end goal that we're looking for. Thinking about the physical layout equals performance. The query engine will not be able to index delta tables as you would have done with SQL Server tables, but it will be able to skip files. Okay, and that is basically what we're doing with clustering and partitioning. It's all about skipping files. So in the SQL Server index, you would be looking at on what row pages is the data that I'm looking for. With partitioning in particular, but also with liquid clustering, we will be looking at in which Parquet file is the data that I'm looking for. Okay, so that we don't need to read everything and then throw away most of it in order to give an answer. If we have a bad layout, again, we need to do full table scans. Just like in SQL Server, that is a waste of memory, a waste of compute power. Your queries will be slow, your users will be frustrated, your credit card will be burning, and maybe Microsoft will be happy because they get a lot of cloud spend then, and their stock price can go up and up and up. But in the end, we need to have happy customers, I think, and then burning through their Azure credits is not something that is good for them. So let's look at some Fabric specific enhancements, because we do get some freebies with Microsoft Fabric in the optimization of delta tables. What do we get? We get V ordering, which is basically the Vertipack friendly layout for Parquet. Vertipack is the engine that runs DAX and Power BI semantic models, where you have a in-memory column stored compressed database. And that same ordering is being used in Fabric delta tables by default, which means that for Power BI semantic models, we can easily read data out of delta tables on Fabric, which makes read operations much faster and much cheaper. So we get it for free. It's included, and you don't need to do anything there. We also get Direct Lake, and that is the next step basically in this ordering process, because Power BI queries your delta tables without needing to import the data into Power BI semantic model, so you can directly read your data. However, that means that the layout matters even more, because you will be doing many read operations against your delta tables. You can imagine that if you have an ELT process and you process your data lake maybe once per day or twice per day or once per hour, whatever, it's a batch processing, right? But you process it only a few times. Oops, there is something not going right. My apologies for that. You can imagine that if you do an import process in that ETL, you will hit your delta table once during the Power BI refresh, and then all the queries hit just your Power BI semantic model and not your delta tables anymore. But with Direct Lake, you skip that, and then your Power BI reports will be doing read operations against your delta tables. So layout matters even more if you do Direct Lake, because you will get many read queries, and it will really be a lot of queries against your delta tables, because with every click, every filter operation, every drill down, everything that you do on Power BI, it will generate a query against your delta table. This ordering is enabled by default, but the layout optimization is still your job. So that is something that we still have to do ourselves. So what do we have actually in our optimization toolbox? We have 4 tools for faster delta tables. The first one is partitioning, and this is the one that people always jump to. However, as we will be seeing today, this is not the one that most people need all the time. The second tool we have in our toolbox is liquid clustering. The third one is compacting your files. It's called the optimize command. And the fourth one is removing obsolete files. It's called the vacuum command. The last two are less important. I think the first two are the most important, but we will be looking at them at all four of them during the demo today. All right. We have set the stage about why we should optimize and how we should optimize. So now let's look at partitioning and liquid clustering and then go into Fabric itself. So what is partitioning? We call it the classic optimization because this was basically the first one and for a long time the only optimization that we could do within Fabric. And what partitioning is, it is basically physically splitting your data into folders. It will force the engine to create multiple Parquet files. So in our previous example, we had a delta table with the delta log, the transaction log, and then we had Parquet file 1, 2, 3, 4, and so on. But now we have a folder called partition1 with with Parquet files in it, and then a folder partition2 with Parquet files in it. All right. This is great because it enables partition pruning. You only need to read relevant files. So if you partition your table by a column that you will filter on, and you filter on that column in your query, then we can skip all the other partitions. We dive into only the Parquet files that are relevant to our query. So we can, if we have a multi-billion row fact table, and yes, they exist, we do have them with quite a few of our clients. You don't need to read the multi-billion rows if you need to do a select statement or an aggregation. You only need to do that operation actually on the data that is actually needed for your analysis. And of course, this is perfect for really large tables and thinking in the 100 million plus range. In number of rows speaking, that would be a very good way to, or that would be a very good candidate to start thinking about partitioning. Of course, we partition on columns that are used in filters. If we partition on columns that are not used in our filtering, then we're partitioning for nothing. Then we're basically creating more files for the engine to read, and that's not a good thing. But if we partition our larger tables on columns that are used in filters in our queries, that will actually speed up the queries and make the queries a lot cheaper to run. But we need to be choosing the right column. So how do we choose the right column to be partitioning on? Since we now know that we will physically split a table based on a column value, we should be using low cardinality columns like region or date or maybe brand on a product table or something like that. We will not be doing this on primary keys, on anything else that has a very large number of distinct values, very high cardinality, because it will blow up our table and will create many, many, many small Parquet files. Okay. So we want low cardinality columns, and we want columns that are often used in filters. And there you see it. We can only do this, or we should only do this, for tables that we have a very predictable query pattern for. We don't want to be over partitioning. I had a client with it was a smaller consulting firm. I think there are 100 people, and I mean, they write hours. Their timesheet lines is one of their most important fact tables. But then again, if you're a consulting firm with 100 people, how many hours can you write? It's not that many. They don't have that much data. Maybe it's a couple 100,000 rows. And they started talking about partitioning and making things more efficient. That doesn't work, right? So we should not be over partitioning, because if we create too many partitions, we will have very small files in our delta table. There will be very small Parquet files. What that means is that there's a lot of overhead because we now need to read not just one file or a couple of files. We now need to read many files into memory. And that's a lot of overhead. We need to find the file, we need to open it, we need to navigate to the file, we need to then read it into memory, we need to combine the data from all the different files. So there's a lot of overhead in that process. If we forget to filter our partition columns in queries, we will get all files. Okay, so let's say we filter on product brands, but then we are partitioned by, I don't know, a customer region or something like that. We will actually read data from all of the files. We will put all of that Parquet data in memory, and then we start filtering there. So that's not that efficient. So we need to think about over partitioning in this way as well. If we have an unpredictable query pattern, this might not be the best thing for you. And it's definitely unnecessary for small and medium tables. And later on, I have a little overview of what I think is small or medium, or at least what is too small for partitioning. So when is partitioning great? It is not the silver bullet. However, it is a good thing for some cases. we think partitioning should be looked at as an optimization strategy for very large tables. And with very large, I mean 100 million rows or more, or 100 gigabytes of data or more. Why 100 million and not 95 million? I don't know, because 100 million is maybe a nice round number, but it is an order of magnitude that we start looking at. If we see a 1 million line table, we will not be thinking about partitioning. If we see a 100 million line, or 95 or 120 million or whatever, partitioning might be on the table depending on some other factors, such as the consistency of our query patterns. If we always filter by X, let's say we have a multi-company setup with billions of rows in a fact table, and users are always filtering by company, then the company column might actually be a very good example to be partitioning on, because it's a very consistent filter pattern. There will always be filters on that column, and it will reduce the row size quite a bit if we can then just look at those files. We can even start looking at combining partitioning with clustering. We'll be looking at clustering in a bit, but combining clustering and partitioning will actually be very nice, because then we can get multi-column pruning, right? We can start looking at smaller subtables, if you will, partitions, and then within those partitions we can optimize using liquid clustering. That's actually quite nice. So speaking about liquid clustering, let's look at what that actually is. We have seen that the limits of partitioning are that they only work for a fixed set of columns. They are bad for high cardinality columns. And if you don't filter on your partition columns, you will still be scanning all of your files. That means that you require a fixed schema. It's difficult to maintain, and it's basically impossible to change your partitioning on a later date. So you create your partitioning. If you want to change it, you need to drop your table, reload it with a new partitioning, right? You cannot just change the partitioning on an existing table. So that's some of the limits that we have. And liquid clustering tries to solve that by organizing data by columns without physical file splits. And that means that we might still have more than one file in our Delta table, more than one Parquet file in the Delta table. However, we are not forcing the engine to split files because there is a filter on a partition column. Rather, the engine is trying to optimize for a certain data volume for each file. And it is then sorting the data by your clustering columns in order to make sure that rows with similar values end up in the same files, end up close together, reducing the I/O operations on our tables when we read for filtered queries by helping to skip data. And in the visual here, you can see a little example of that is that when we do liquid clustering by customer ID, for example, we could have a Parquet file number 1, number 2, and so on, where there is certain customer IDs that are grouped together. So if you filter for a customer ID or for multiple customer IDs there, we might be able to skip 1 or 2 or a lot of files depending on the data distribution. What is good to mention is that liquid clustering is applied incrementally during write operations. So we start inserting and updating data. The clustering is being updated, and that's actually quite nice. You don't need a maintenance job to force clustering to keep working. You do need maintenance jobs still for other physical layouts, mainly for removing stale files and and to make sure that your files are large enough actually for the Spark engine. But just to maintain your liquid clustering, you don't need to do manual maintenance, and that's actually quite cool. So we have already this ordering in Delta tables in Fabric, and we can enable clustering ourselves. So why one or the other, or maybe both? Applying ordering, the Z ordering is a batch operation. We need to run the optimize command actually to help the engine rewrite the data in our Delta tables. Where liquid clustering is happening on write, it's happening incrementally. We don't need to do anything for that. The compute costs are also lower in liquid clustering because it's happening very gradually. Okay, with optimize commands on a table, we need to read the data into memory, sort it, and then write it back, and that's quite a compute cost that we incur. Still, it is good to do the optimization, maybe in a weekly job, maybe in a daily job, depending on how often you update, insert, or delete data. But you do need to do this on a set schedule. Liquid clustering there is automatic, and the flexibility, it doesn't matter that much. I mean, the flexibility for Z ordering itself is quite high, but it's a manual operation, whereas for clustering it will be applied automatically. So when do we use liquid clustering? We can use it for more high cardinality filter columns. So maybe in our multi-billion row fact table example, where we have a couple of company IDs that we want to filter on, that's a very low cardinality filter. But maybe customer ID is more high cardinality. Maybe we have 500,000 customers. We do not want to create 500,000 partitions, right? That's a bad thing. But maybe clustering on those 500,000 will be a good thing, because we will not be creating separate files for every customer. No, we will be grouping files together, or actually grouping rows of data together, where customers that are closer together are actually stored physically closer together as well, meaning that we can read that data more easily. And that also means that we can start thinking about using liquid clustering for smaller tables than we would for partitioning. We say medium to large tables between 10 and 100 million rows, or 10 and 100 gigabytes. Again, this is just a starting point to start thinking about liquid clustering. Maybe a 5 million row table is also very a very good candidate to be helped with liquid clustering. But this is the general order of magnitude in which we see that liquid clustering actually helps us. It also helps with evolving query patterns, and there's a typo on the screen here. It says patterns. I mean patterns. It is quite easy to change our liquid clustering over time, right? We don't need to drop tables and reload them. And it works well standalone as well as combined with partitioning. As I mentioned in the partitioning chapter, we can do partitioning on a low cardinality column, and then within those partitions we can start applying liquid clustering to get the best of both worlds for our very large tables. So let's look at Microsoft Fabric. This is what we all came for, right? And we grab Safari here. Well, let's not do that. Put this one to my other screen.
Before you jump into the your demo, so there are some comments maybe that can be relevant a bit. Let me just show some of them. There was a comment from Cyclogen. Without knowing much about it, I would assume partitioning is only useful if you have a consistent partition key to filter on.
Yes.
Yeah, and another comment is in a lot of cases with Power BI, you're looking at all of the data in some form, aside from date filtering, for example.
That depends on how you read data from Fabric into Power BI. So if you do imports into Power BI, then yes, you will do a full load basically, and then it maybe doesn't really matter if you partition or not. However, if we do direct lake, then every Power BI query that you run, so the Power BI report layer itself, the visuals themselves are then generating queries against Delta Lake. Then partitioning and liquid clustering might help if those queries are actually filtering for your partition columns.
Yeah. And maybe for the naming convention, do we know why they named it liquid? I assume because it is fluid and continuous.
That's my assumption as well. I do not know. I was not consultant when this name was chosen.
Yeah. Cool. Yeah, just I wanted to mention these comments. Thank you very much, but
Awesome.
guys, for being active in the chat. Yeah, please ask questions, and Bas is here to answer them. Yeah, go on.
Awesome. Yeah. All right. Okay. So we're looking at my web browser right now. We're looking at a Microsoft Fabric notebook. We see here it's called Delta Lake Optimization Sample Notebook. So what I've done, I've downloaded the New York City taxi data. It's I think probably today over 4 billion rows of data. And I've taken the 2024 data, which is probably 300 million-ish rows of data. I've taken that data into a separate demo table where we could be looking at how this stuff performs. All right, so let's quickly start running those queries in here. And now you will see probably that they are actually quite fast. This is something that I'm struggling with, that Microsoft is making our life a little bit harder by actually optimizing Fabric. And maybe the datasets are just too small to actually show the the benefits here. But basically what I've done now, if I've created a very messy version of our table, I've created a partitioned version of our table where I partitioned by date, and then I've done some clustering as well. We see now in 6 seconds, 4 seconds, and 5 seconds query time here when we start summing an amount, the fair amount for a taxi right. So this is not the best demo that I can give you guys. In the past, it worked better. I don't know. I mean, it worked better. It worked worse, but it was better to show the actual benefits of partitioning and clustering. I don't know why it's now so fast on even the messy tables. However, I have another very ugly table here. It's called this one. We could try reading from this table and see what's happening here. This is probably a very slow one.
Bas,
Yeah, this.
sorry, would you mind
Yeah,
to zoom in a little bit?
I will. Yeah, sure,
Yeah,
of course.
thank you.
All right. All right. So actually, here we are looking at a very badly optimized table that is now taking a lot of time to be reading data from. So here the demo is actually working, where we have the same table, the 2024 taxi data table. The partitioned one is running in 4 seconds. The clustered one is running in 6 seconds. So they are close together, and then we will probably be waiting for a minute or more for our messy version. What do I mean with messy? Let's look at the Storage Explorer, and let's zoom into this one as well a little bit. Why is that Command Plus not working? It is. Okay, so here we are looking at the Azure Storage Explorer, which usually can be used to start looking at your blob storage accounts. However, we can also look at our OneLake storage and at our lakehouses in Microsoft Fabric. So what do I mean with partitioned, the messy one and the clustered tables is the following. If we open this this folder, which is a table containing a delta log and containing Parquet files, we will see that the clustered version of our table is actually a very neatly organized table. The files in this folder are about 300 megabytes, and that is something that I did not choose. The Spark engine chose to write these files. So I basically told the engine, here's 300 million files, put them in a table, and then the engine said, okay, that's fine, I will do that, and I will chunk it up in 300 megabyte files. Why? Because Spark thinks that 300 megabytes is a nice size of data to read into memory and to start doing stuff on. Because we clustered this table on date, in this case, dates that are close together in the same file. So when I now start filtering for a particular date, I only need to read one of these files into memory. When I start reading a month, or maybe a month is not the good example here. If I start reading a week into memory or into my my queries, probably I only need to read one file, or maybe I need to read two files if they are just on the boundaries there. All right, so I can skip reading a lot of this data. Now let's look at, while in the background this is still running after almost 3 minutes. Let's look at how the sorry, not the clustered one, how the partition table is laid out. And if we open this one, we will actually find that there is folders in here for every date of data. I can scroll through the first 100 rows. There's actually more pages in here. But what we see here is that there is a filter for pickup date, and then the actual date of the taxi trips. And then every partition in here contains a Parquet file. It could be multiple Parquet files, but every partition here is basically a table on its own with one or multiple Parquet files, and we see that these Parquet files are quite small. This is a 7 megabyte file. If we look at other partitions. There's an 8 megabyte file. So these are very small partitions. I chose the date on purpose because it's easy to demo. And because if you do then an example where you just pick one date, it's actually quite fast. However, if you start partitioning your data, you end up with 5 megabyte or 10 megabyte files. You have probably over partitioned your delta table a little bit. For today, that's fine. And to show you how the file layout actually works, that's okay. But please do not do this in production. Now for the messy layout, here we are showing that we have over 3,000 files in our table, and we see that we have very small files, only a couple hundred kilobytes. I've done this on purpose. I've loaded the data into a table saying you can only create files that contain 10,000 rows, which is way too small. Never do this in production. However, it allows us to force the engine to create a very, very badly organized table. And as you can see here, there's thousands and thousands and thousands of very small files. And you can imagine now that reading from all of this data will be very messy. Okay. And if we go back to Fabric, we see that after 4.5 minutes, the engine came to the same conclusion that this is the fair amount that the New York taxis in aggregate earned on this day. The same amount that was calculated in 4 and 6 seconds for our optimized tables. All right. Now, why was this very slow? This was very slow because we had to read thousands and thousands of files into memory. And then after it was read in memory, we started sorting through it and then filtering for that single date. And then combining that data, calculating the sum of the fair amounts in order to actually retrieve this number. All right. So this is actually a good example of when it will be very beneficial to partition or cluster. And as you can see, that partitioning and clustering in here, it doesn't really matter. There's maybe a 50% difference, but it's not material. It's only a couple of seconds. Okay, so in this case, there is no big change between clustering and partitioning. Now, if we were to filter for a range of dates, we would probably see at some point in time that clustering would perform faster than partitioning, because with every date that we add to this filter, the partition table needs to read an additional file into memory. Whereas with the clustered table, we can read a range of dates and probably still be reading from the same file. All right. Now let's look at how we can help ourselves find the. Go on. There we go. Find the layouts of our queries. If we run a SQL magic command, we can run a SQL query in our notebooks. And if we then start off with explain formatted, we get the physical query plan for our tables. Now, mind you, this is the ugly table. I'll zoom in a little bit for you guys. This is the ugly table. There is a filter that is pushed down into the query, and we will be reading only the pickup date and the fair amount, which means that we are actually utilizing the delta table column pruning here. We only read the columns that we are working with. We filter for pickup date and we sum the fair amount. However, that is about it. There's nothing else that we can do. So now if we start looking at our partitions table, we do the explain formatted, and we get the physical query plan in here. Here you will see that this query is actually working with our partitioning. Now, if you're not sure whether your table is partitioned in a way that your actual query is able to use it, do the explain formatted commands, run it, and check for partition filters. If partition filters is present in your physical query plan, that means that the Spark engine is using partition pruning, and it will show in this case that we only will be reading our pickup date partition in order to retrieve data. We could now probably say or pickup date, I probably need to use just an or statement here, the 13th. And now it will show us that it is actually still pushing that query, that filter down to the partition filtering, but it is now reading data from two separate partitions. But still, partitioning is kicking in, so our query is benefiting from the fact that we partitioned our table in this case, right? So this is actually quite nice. We also need to read only the fair amount. We don't need to read the actual pickup date from a table, and that's a big beneficial thing as well. If we do not filter on a partition, we need to read the filter column into memory as well and then start filtering. In this case, we only need to read the output columns into memory because we already filtered on that physical level for a date or multiple dates. That makes sense, right? For clustering, we can do basically the same thing. If we start looking at the query plans here, we will see that there is a filter that is being pushed down. However, we need to read the pickup date and the fair amount into memory, because when we start reading one or multiple files, we do not know whether that file contains only the data we need. We know that that file will probably contain the range of data that we need, but still we need to filter down the data in this single file. All right. Now let's start looking at the described detail that will give us a bit more information on things that we can see in the Storage Explorer as well. So here we have the Storage Explorer, where we can see that every Delta table is a folder with Parquet files in the Delta log. If we look at our describe detail command in Spark SQL, here we can get some metadata on our tables. So if we start looking at our partition table, we will see that this table has a format, an ID, and so on and so on. That's interesting. We see that there is partition columns in here. This is a list of objects. In this case, it's only one column, but we can do multi-column partitioning. We will see that there is a number of files. It is not 365. I don't know why. Probably there's a few days missing in my dataset. And I think I created this dataset late 2024, so I'm probably missing a piece of December or something like that. But we see that there's 336 files in our table, and that it has a certain size. Now, if we do the same thing on our cluster table, we can see that we get some other information here. We see that there is no partitioning. However, there is clustering, and we have only 10 files. The data size is approximately the same. And looking at the number of files here means that we have probably a better optimized table. Now, where is my messy one? That's this one, but it's not the proper one. I want to have this one. All right, so here we have our messy table, which actually, it actually contains 30,000 files. So I was thinking 3,000 here from the Storage Explorer, but that is probably, the folder statistics were probably not updated here. We actually have 30,000 files in this table. Why? We created the table to be very inefficient, and that means that we can show you how this is done. How can you create a very unoptimized table? If you want to do this on your own for your own testing, you can read data into a data frame. You could even repartition that if you want, and then you can write your your data frame back to a Delta table, where you can set the option of max records per file to a very low number. Do not use this in production, but if you do that, then you will be creating a lot of files for your Delta table, right? So this line number 8 here is really messing up the physical layout of the table, but it allows us to demonstrate the effects of having an unoptimized versus an optimized table. I think we are now there with looking at how we can optimize your table, what the differences are in file layout and table layout for unoptimized tables, for partition tables, and for optimized cluster tables. One thing I want to show is how we can use the optimize command. This is a manual command. This is usually with our customers, we schedule just this in a weekly batch operation. Let's run it right now, and I hope that we can run it actually very quickly here. Probably not. It will probably take a little bit too long. But what the optimize command is doing, it is running a query against the entire table. It's basically reading the entire table into memory and then writing it back to the same table. And what that will do is, we start looking here at a storage explorer, it will read those 30,000 files that we've created that are too small, and it will load them back into a table with probably that 300 megabyte sweet spot per file, creating a table that contains the same data but has an optimized file layout. Now, why would we do this on a daily or weekly basis? You can imagine that if you have a large data set that you frequently update or insert data into during a daily or an hourly ETL process, you are not actually inserting data into the latest Parquet file. So if we're looking at the clustered files here, those are pretty optimized. This Parquet file number 9, when we do an insert into this table, we are not inserting a record into this Parquet file. We're actually creating a new Parquet file with just one record in it. Now, if we start doing that every hour, you can imagine that the number of files in the table will blow up and the query performance will go down. Okay, and then by running the optimize commands, we will be reading all of the data back into memory, writing it back into an optimized format, enabling either clustering or partitioning or just the general Z-order optimization that Fabric comes with, in order to give us faster and cheaper queries. Now, this will probably be taking a little bit too long to just be looking at for the demo today, but just know that you can run optimize against your tables, schedule this in a weekly batch file, or maybe if you do very frequent updates in a daily batch file, batch operation, in order to compact the file sizes. Now, the last thing that we don't need to look at is the following. Let's say we have our messy table in here with, now there's a process writing against this, so it's a little bit slower. We will we will end up with, we cannot see it right now, it's not writing. We will have files that are tens of thousands of files in the 100 or 200 kilobyte range. And then we will end up with a couple of files in the hundreds of megabytes range, right? It is not throwing away all the old data. Why? We have delta time travel. That means that old data, stale data, is being kept in your delta tables. Your delta log is not pointing to it anymore if you do a current read of the data. However, you can read the table as if it were yesterday or a couple of days ago. Okay, that's the time travel component we get with delta. It is quite cool. However, it also means that we still have a lot of unnecessary files in our table that might, and they might never be hit again. If we want to clean those up, we run the vacuum command, and the vacuum command will basically tell us, it will tell the engine to optimize a table and to retain a certain number of history, usually in hours. And if you say, I want to retain 0 hours, we need to set a configuration in here. Do not be thrown off by the fact that this configuration is called Databricks. We're actually not in Databricks, we're in Fabric here. But we need to disable the retention duration check. If we set it too low, we will get a warning that that we might be throwing away data that could be needed. If we set this to false, we are allowed to throw away all of the stale data that we don't need anymore, and we will actually end up with a table that only contains the current files, which are the files that the delta log is pointing to. Now, that was the end of my demo. We're still looking here at a screen that's running. Let's quickly dive back into the last couple of slides. With Shift F5, that should be working here. Let's wrap up the presentation and start thinking about file maintenance, because we now know how to physically lay out our delta tables with clustering and partitioning. However, one thing we need to do is actually maintain those delta files. As I have showed, the optimize command will merge smaller files into larger files. That will improve your scan speed and read overhead. And we usually schedule this after frequent inserts and updates, or just do it weekly. Depends a bit on how you process your data platform. And then vacuum deletes the old files that are not in the Delta log anymore. By default, Fabric retains 7 days of history. You can set your tables to retain up to 30 days, I believe, or maybe it's even indefinite these days. I'm not quite sure, but by default, it's 7 days. And by running vacuum, you will be freeing up some storage. And this is something that you will need to do after optimize commands. So if you do an optimization every week, please also do the vacuum every week. Or if you have done very heavy delete operations, then the vacuum might help as well. We will be targeting 128 to 1024 megabytes per file because the Spark engine likes that range of file sizes, right? If you make the files larger than that, it will be very difficult to load that data into memory. And therefore it will you will see your performance go down. If you make your files a lot smaller than this, in the example where I had only 10,000 rows per file, reading the files doesn't get slower, but you need to load more files. Obviously, that's a problem there, and we want to force the engine to sit in that sweet spot between 100 and 1,000 megabytes per file, basically. So in conclusion, the performance of Fabric Delta Lake is about file layout more than just compute power. Okay, we cannot just put in another CPU. We need to think about how to lay out our files. For very large files and for very predictable queries, we can use partitioning, and then liquid clustering improves file skipping in a more flexible way, and also for a little bit smaller tables, for these medium-sized tables that are in the 10 to 100 million rows range. You can also use partitioning and clustering together, and you can imagine that the exact same file layout that you saw for the clustering can be used inside of your partition folders as well. Some recommendations: use partitioning when you have a very fixed low cardinality filter column. Your tables are very large. Use clustering when your filters and query patterns can evolve over time, and you need to maybe update the clustering once in a while. And your tables are a bit larger, but they don't necessarily need to be as large as for partitioning. If your table is below 10 million rows, don't bother looking at either one of those two options. However, if your tables are below 10 million rows, even then do the weekly optimize and vacuum, because with frequent updates and inserts you will end up with many thousands of files anyways, even in your smaller tables, and your data platform will be happy if you optimize it once in a while. If you want to verify your skipping behavior, use the explain and input files functions that we have. We did not look at input files, but we have the input files in the notebook that I will be publishing to my GitHub, and there you can verify that you're actually skipping data with your queries. And then, as I mentioned, do the weekly maintenance in order to optimize your file layouts. I'm available for Q&A, so if there's any questions, please ask. If not, then I'll thank you for being here.
Cool, awesome. Thank you very much, Bas, for your great session. There's few questions from Sam. That is also my question. Some of them. So can you just one more time share your GitHub, as you mentioned, your notebooks and all the codes and presentation is in your GitHub. And you
definitely.
can just put it in the chat and in the public chat, and it can be shown here.
Yeah, I will put it in the chat here. Let's see. Where is the chat window for me?
Or even you can just share your screen again.
Yeah, maybe putting it in the chat would be easiest because people can then copy paste. But
yeah,
I cannot. I can read the chat, but I cannot chat back. It seems.
Oh.
I'll put it on the screen then.
Okay, so let me share the screen one more time.
There we are. Yeah, perfect.
Yeah, guys, here's the link to the GitHub repo, github.com, Bas Land presentations.
Yeah, and I believe on my blog I also have a blog post about both about partitioning as well as about clustering with code samples and so on.
Yeah. Awesome. So the other thing is that is Sam asking if I missed this spot. Where is the code to create liquid clustering? Is it
Yeah,
something that you
yeah.
have shared or?
I've not shared that today. However, if you can put back the screen,
Oh, sorry, I'm
then I can show
awesome.
that real quick. So let's clear that here. Let's see if the example is in here. No, it's not. But we will probably have something in here. Partitioning clustering test. This is where we are. So zoom in a little bit. So for partitioning a delta table, this is just an example where we will create a delta table with a table name with some columns and data types, and then we can use the partition by in here. And actually, this is an example I created earlier. We did not demo this today, where we can have pickup date and taxi type ID, but we can we can partition by a set of columns, one or many columns. Do not overdo this, obviously. But this is how we can create partitioning, and in the same way, we can start creating clustering by using delta table.create.cluster by.
Awesome, thank you.
All
And
right.
the codes are available in your GitHub, right?
Yes.
Awesome. Yeah, Sam, I hope you got your answer. And another question is coming from Sam. If setting retention equals to 7, for example, this means we cannot time travel prior to 7 days?
That's correct. That means that Fabric is actually cleaning up all our files. What we do in our platforms is we will create what we used to call in the SQL Server world a persistent staging area in the silver layer of the Medallion architecture, where we do actually an indefinite time travel ourselves, and we do not rely on Delta Lake time travel.
Okay. And how to use partitioning and clustering while balancing between the pros and cons of each approach.
Yeah, that's a very good question, and that's actually where the art of being a data engineer is. As I mentioned in my presentation, partitioning clustering have their pros and cons, where you should be looking at them if your table is large enough. So from 10 million rows up, I would be looking at clustering, and then again, I would be clustering on on columns that I use frequently in filters, in aggregations, and so on. And the same goes for partitioning. If I have tables that are in the 100 million row range or more, I will be looking at partitioning if I can define a column or maybe 2 or 3 columns that are frequently used in filters and that are low cardinality. If you do not do that, then the cons outweigh the pros, basically.
Awesome. Thank you. And another question, how to use partitioning and clustering together while, oh, sorry, it was the same question. Uh, and we have a comment from Sanjay, never received the Microsoft voucher from Andy Cutler session. Yeah, just if you haven't received that, just send me a message in on LinkedIn or send a message to our LinkedIn page for Microsoft Fabric Cafe. We will just follow it up, and for sure you're gonna receive it. So, guys, maybe for the other sessions we will have some prizes, the same prizes. So yeah, just added the block to my feed reader.
That's
SQLGen, yeah,
awesome. Thank you.
awesome, yeah, yeah. And Sam, how the question from Sam, how liquid clustering can help in real-time streaming use case, or is it only for batch?
I don't know. I've not played with real-time streaming in Fabric, so I wouldn't know. For now, we use it in batch processes only, and there it seems to work really well. Real time, I cannot comment on that.
Awesome, cool. Yeah, I don't see any more questions. Guys, if you have got any other questions, you can feel free. When we actually do the sharing of the recording of this session on LinkedIn, of course, you can just ask your question underneath of that post with tagging Bas, and he will answer those questions for sure. Thank you very much again, Bas, for being here. I'm gonna just share my screen quickly, so our session with Bas is completed, and the recording is going to be available immediately on our YouTube channel. So, of course, you need to rewatch it. And as Bas shared the GitHub code, you can just do the practice and go through that. And if you have any question again, come back to us. Our next session will be with Ahuja for next week, building scalable enterprise-ready data solutions with Microsoft Fabric. So stay tuned for the announcements. And again, thank you for attending. Just follow us on YouTube, LinkedIn, and just join to the user groups on Microsoft Tech Community and Microsoft Fabric community to just help each other, and rate this session on Meetup, and we will just look forward to see your comments. Uh, just thank you for Bas, and that was a great session. And just comment here. There's a catch when using cluster by column and clusters by auto. Is is it a cache or a catch? Yeah, cool.
I
Yeah,
don't know. All right.
yeah, yeah. If you make it more clear, Sanjay, it will be answered later. Cool. If you have
Definitely.
anything to add, Bess, feel free. If not, we can just wrap up the session and hoping, actually, wishing a nice weekend for everyone.
Thank you for having me and enjoy the weekend.
Thank you very much for being here.